This is Pre-Calculus B, Unit 5, Lesson 4, Direction Angle. So we're going to do some arithmetic and some work with some vectors given the angles and magnitudes instead of just given the rectangular component vectors. Now there are two approaches to this. You can use trigonometry, law of sines, law of cosines, and solve for missing angles and things of that nature. But the approach we're going to use here is we're going to convert into rectangular form and then do the arithmetic on those. So let's say here we have this scenario. I've got a heavy box that we're going to be moving. Okay, so here's the box. And Sam is pushing on the box. He's pushing on the box at an angle of 30 degrees because he's taller than the box. And so he's pushing in this direction on the box. Okay? And so this is his force, which is a vector. Force is a vector. It has magnitude and direction. Okay? And force 1 is going to be 30 degrees, at an angle of 30 degrees to the horizontal. And a magnitude of 150 newtons. Okay. Meanwhile, Alex is pulling on the box with a rope at an angle of 45 degrees. Okay. And in fact, let's do this here. Let's move this here. Okay, move things down a little bit. So Alex is pulling on the box, and he's pulling on the box at an angle of 45 degrees to the horizontal. He's got a rope that he's pulling on, and he's pulling at an angle of 45 degrees, and he's pulling with a force of 200 newtons. So force 2, the magnitude is 200 newtons. Okay, and he's pulling at an angle of 45 degrees. Okay, all right. Now we can find the resultant vector by stacking head to tail or by the parallelogram method. The method I'm going to use here is to convert these to rectangular form and then perform the addition. Okay, to find the resultant. And you may recall this formula here. So if we have a complex number z, it can be represented as r cis theta, right? Which stands for r cosine theta plus I sine theta, where this is the real and this is the imaginary part of the complex number. Okay, and I bring this up because this has a lot to do with what we're doing here. Now a vector can be represented as the magnitude of the vector times the cosine of the angle times the unit vector I plus the magnitude of the vector again times the sine of the angle times the vector j. You see the similarities? It's really the same formula. It's just a different context, but it's the same idea. We take the magnitude, which is the r, and we take the cosine of the angle for the horizontal component. We take the sine for the vertical component. That's really all this is. So let's do this. Vector f, vector f1. Vector f1 is, and I don't need the magnitude on that, just vector f1. vector f1 is the magnitude of the vector, 150, times the cosine of 30 degrees. Now, here this is, if I superimpose this down here, this is negative 30 degrees, right? Okay, stacking them, putting them in the same origin point. So cosine of negative 30 degrees times I plus the magnitude of the vector, 150, sine of negative 30, j. Okay, now I don't usually write this much out because I know the cosine of negative 30. Cosine of negative 30 is root 3 over 2. So 150 times root 3 over 2, I, plus 150 times the sine of negative 30, which is negative 1/2. Yeah, that's negative 1/2 times j. And once again, vector f sub 1, force 1, is 150 divided by 2, 75 root 3, I, plus 75, or minus 75, j. And so we've expressed F1, force 1, the force of pushing, as a vector in component form. 75 root 3I minus 75j. Okay, let's do the same for the other one without going into as much detail. So force 2 in rectangular form. It's going to be 200 times this is the horizontal component, right? Cosine, the horizontal, root 2 over 2, or 1 over root 2. But root 2 over 2, I, plus 200 times the vertical component, root 2 over 2, j. Okay, simplify a little bit. F2 is 100 root 2, I, plus 100 root 2, j. Okay, and now once it's converted, the idea is we can find the resultant vector quite easily by addition. So F1 plus F2. And I'm just going to add straight down. 75 root 3 plus 100 root 2 I plus, plus negative 75, okay, plus 100 root 2 j. Okay, and there we have it. Okay, so this is the resultant vector here. Now, the other thing that we need to worry about here is how do we find the direction? Another objective. How do we find the direction of a vector? Let's use this example here, and let's find the direction. Let's make a new one here. So you're given something in rectangular form. So you're given, say, vector u equals, and let's give it an ij form, negative 4i plus 6j. Okay, so what is the direction? The first thing you have to keep in mind is what direction does it go. Negative 4, 6, 2, 4, 2, 4, 6. So you have to consider the quadrant that we are in. Because remember, the inverse tangent function has domain restrictions. And so we do need to keep in mind what direction it is pointed. Okay? But we say tangent of theta Now this is theta from the positive x-axis. Theta is measured from the positive x-axis. Tangent of theta equals negative 4 over 6, or negative 2 over 3. And we say theta is arctangent of negative 2/3. Okay? And let's go ahead and do that here. Grab our calculator. Oh, Desmos! Here, Desmos, here, boy! All right, Desmos. Des does the most. Not the least, but the most. Okay. Desmos.com. And arctangent. Make sure you're aware of what angles, what units you are. I'm going to go into degrees, but there are certainly cases where you will need radians, and you need to be comfortable with both. But just be aware of what your calculator settings are. Okay. Arctan of negative 2/3. Okay. Now it's going to give me a negative 33.69 degrees, right? Which is actually down here. And negative 4/6, negative 2/3. And I just realized something. I did it backwards. Let me fix this. Tangent is rise over run. It's y over x. And you're probably been screaming at the video going, that's not right. Because it's not. All right. Let's go here. So it's 6 over 4. Okay. Because it's y over x. Negative 6 over 4, which is negative 3 over 2. I just realized that as I was getting an answer that didn't make sense. Negative 3 over 4 over 2. So negative 3 halves. There we go. Okay. So negative 3 over 2. Y over x. Okay. Negative 56.31. So that's this angle right here. Negative 56.31 degrees. But that's in the wrong quadrant, right? And that's because of the restrictions. So we need to add 180 to that, right? So negative 56.31 plus 180. Or you can think of it as 180 minus 56.31 if you look at it in terms of this angle here, where this is 180. And this is 56.31 degrees. Okay? Right? And so what do we get? 20, no. 180, so 25.8. Sorry. 180 minus 56. Yeah. 120. There we go. 123.69. Just doing it in my head. All right. So there we go. 123.69 degrees. So be aware of what quadrant you're in when you're finding the angle. And don't make the same mistake I made. Put y on top, x on the bottom, the vertical over the horizontal. All right.